Hello and welcome to this video on the topic of supervised learning. Here we will be discussing the key concepts of regression and classification. So let's begin. So in order to motivate this topic, let us assume that you want to sell a house and you want to figure out what the selling price of that house should be based on some properties that you had at your disposal. Further, assume that you have a data set of various houses that represent their properties and the selling price. So, some of the examples of the selling price of the house for the properties of the house could be the size of the house in feet, the number of bedrooms it had, what is the age of the house, that is, when it was built, and its distance from the nearest city center in miles. So, these are some of the examples of the properties that could be relevant while selling a house. So, based on this type of features or properties, let us assume that we had a data set like this. So this is a data set of 5 houses in which I had the properties that of size of the house in miles, number of bedrooms the house had, the age of the house, that is how long it was built ago, how long it was built. Distance means the distance from the nearest city center in miles, and the selling price, that is the price at it was sold. So assume that the house one had the size is 1500 square feet. It had 3 bedrooms. It was built 10 years ago and it is 5 miles away from the city center. So assume that it was sold at say $300,000 maybe. So this is our data set. Similarly, we have the data set of 5 other houses. So what is our objective? So our objective is to learn a function f that takes on these values x1, x2, x3 and x4 as input and returns a value y hat such that this value is approximately equal to the true value y. So using the empirical slash observed dataset, for example, the house price dataset that I had, I want to learn this function f. And the key property of this function f should be that for the house one with the size 1500 feet square feet, 3 bedrooms, 10 years ago, built 10 years ago, and 5 miles away from the city center. So for the function f with for the values 1500, comma 3, comma 10, comma 5, it should predict a value y hat such that this value is approximately equal to 300. So this is for house 1. So I'll apply the index 1, which is equal to y1. Similarly for the house 2, y2 hat must be equal to 2000, comma 4, comma 5, comma 3. This value must be approximately equal to 400, which is equal to y1, y2. So similarly, I should get y3 hat, y4 hat, and y5 hat, which are the functions of their respective properties. So this is my key objective. So now after I have figured out this function, I can predict the values for any unknown value up to a certain precision. So for example, I want to predict the price of the house that I wanted to sell so that I create a profit or at least don't go for a loss. So now assume that I have a data set which only contains the house size and the house prices. So assume that the data set only contained the house size and the price at which it was sold. So assume that the data set, if I create a scatter plot of that data set, it looks like something like this. So it is quite logical that the price of the house will increase with the size of the house. So the bigger the house, the more price it will be, more costly it will be. So on the x-axis, I have the house size, and the leftmost value is the lowest size of the house here, and the rightmost value is the highest size of the house. So it is from left to right in the increasing order. Similarly, the y-axis is the house price. So bottommost value is the lowest house price, while the topmost value is the highest house price. So assume that this is the data set of different houses that was sold based on the house sizes. So my supervised learning task is to figure out the function f such that it is able to predict the function. It is able to predict the price of the house based on the house size. So in this case, I want a function f such that f of house size is equal to house price. So in order to do that, there are many possible choices. I could create a fit a straight line that passes through this data set and give me an approximate value. Or maybe I can predict a function like this that is not linear. And similarly, I could create a function which is more suitable, which is the green line, and is able to model the data comparatively better than the previous two examples. So now, formally, how can I describe my supervised learning problem? So I can describe it as figuring out a function f that takes the values from the input space D and outputs a value from the output space O, such that f of x is a good predictor of the corresponding value y. So this is the key task, basically how to figure out this good prediction for any corresponding value y. So now again, based on this value of y, I can categorize my supervised learning problem in two ways. So first is the regression task. So if the output variable can take any possible value. So for example, I want to predict the house price based on some features of the house. Or maybe I want to figure out the stock price of a certain stock based on the values of the previous day. In the regression problem, the value of y, variable y, output variable y can be anything. So for example, so for example, if I measure my weight every day, so it can take any value like 80, 80.5, 80.1, or maybe 79.9, or maybe 79.8. So it can take any possible value. This is the example of a continuous value, and if I want to predict this value based on some features, this will be a regression task. Similarly, the second paradigm of supervised learning is the classification. So if the output variable can take on a discrete set of values, then it is a classification problem. For example, if you have a data set of patients having diabetes, and the output variable based on some features are whether the person had diabetes or not. So diabetes, yes or no. So another example for the classification problem could be image recognition. So image recognition task is basically you have a given set of pictures, and you want to figure out what is inside that picture. So for example, the you could have a images of various breeds of dogs, and you want to figure out which of the breeds of the dog the picture is in. So the picture could have the image of a Labrador, or maybe a German Shepherd, or a Siberian Husky, or something like that. Similarly, another example of the classification problem could be fraud detection. So, for example, if you assume that you have a data of customers of a bank, and based on some historical values or the parameters of a customer, you want to figure out whether we should give the person a loan or not. So, this is the two paradigms of supervised learning. But one of the most challenging problem with the supervised learning problem is how to figure out this function f so that it generates a reasonable output for any given input. So I have already told that I want to find this function f, but the main idea is how to figure out that. So for that, we have two possible cases. One is applying a restriction bias. So in this case, the idea is to restrict the class of functions for f. For example, I can only consider the linear functions. For example, in the house size versus house price dataset, I had various possible functions for fitting the dataset. So I could use a linear function of the form y is equal to mx plus b, which is basically a straight line. Or maybe I could use a quadratic function, which is like mx square plus bx plus c. Sorry, ax square plus bx plus c. Or I could use a cubic function, which looked quite relevant in the green line that I had showed. So ax cube plus bx square plus cx plus d. A cubic function like this, or in general, any non-linear function, linear or non-linear function. Like for example, trigonometry function could be sine of ax plus b, or any non-linear function in general, y is equal to e to the power x, or something like that, e bar ax plus b, or something like that. So I'm applying a restriction bias on the possible value the function f can take. Another idea could be to apply a preference bias. So in this, the idea is to assign some likelihood or a probability to every possible function. And the probability should be assigned in such a way that I assign higher chances to the functions that seem more probable. So this is the main idea. However, these two possible biases also provide further challenges. Uh, so in the case of restriction bias, the challenge is so in the house price versus house size data set, it was one dimensional data, so I could easily plot it on a graph and see how the function looks like, how the scatter plot looks like, and I could initially guess that the okay my function f takes could take this possible value form. Similarly, I could also do this for a two-dimensional data set. I can plot a three-dimensional graph and I could see how what the shape of the my data set could be. However, when the dimension of the input data set d, like x is equal to x1, x2 till xd, if this dimension is quite large, like d is much greater than 2, greater than equal to 2, it is quite it is impossible to plot them on a graph and see how the behavior of the function or the data set is. And we it is quite tough to figure out what my function f what the form of my function f could be. So this is one of the key challenges in the restriction bias. Similarly, in the preference bias, the challenge is that the number of functions, possible functions in a space of all the functions is infinite. Basically, you have infinitely many functions, and it is extremely hard to assign probability to every possible function, and thus this creates a challenge for the preference bias. So these are the two most important challenges and how we can deal with them in the supervised learning classes. So this is all for this video. Thank you for watching. In the next video, I'll be talking about one of the most classical supervised learning algorithms, that is called the linear regression, and we'll discuss the mathematical concepts of related to linear regression.